Welcome. My name is Daniel Michael. I'm with the BioLink Depot, and we're excited to have Mary Ward, a biohacker and co-founder of Counterculture Labs. Great to meet you.
Hey, great to meet you too.
Have a seat right here. Okay, Mary, I'm very excited to hear about the biohacking and also your experience at Counterculture Labs and this project. But before we get into that, I really want to ask you a little bit about yourself and how you got into all of this.
I hail from Texas. I graduated from the University of Texas at Austin with a Bachelor of Science. Now, when I moved out to the Bay Area, I had no plans. I was just following a dream of a TED Talk. I talked of a community lab down in South Bay, BioCurious, and I wanted to get involved. But before I moved out here, I didn't realize how big the Bay was. And so went down to BioCurious a couple times, met up with some of the regulars there, and found out a couple of them lived in East Bay, and we're trying to make a lab in Oakland. And that's when I joined. We were meeting next to a hackerspace and talking about the idealisms and trying to improve on the spaces, the community labs that already existed.
Okay. And when you first started this idea, it's about biohacking. Many of our people might not know what biohacking is. Can you explain what that is?
Biohacking is just doing and researching biology outside of academia or industry. And so that's a great opportunity for people to get more in touch with science. In the United States, actually, the government spends more money funding research than anywhere else in the world. But 80% or something crazy like that of our population doesn't even believe in evolution. So there's definitely a disconnect. So biohacking is really just getting the lay people without a strong science background into the lab, learning what it means to do synthetic biology.
You know, a lot of people, when they hear the word biohacking, might have some notion about what that is. It might be a scary notion. Could you explain exactly what biohacking is in a little more detail?
What if somebody nefarious comes in and wants to make a biological terrorist agent that kills us all? That's one of the main fears that a lot of journalists ask me. It's like, well, what about that? I think that those people would be doing the work in their garages. And what our main concern is helping people do science correctly so they don't harm themselves and so they get good science results. And that's what you get in a community lab space. That's what biohacking is about. Now, there are biohackers working in their garages, but they're not going to be making anything crazy. They're normally researching things that nobody wants to research because it's not going to make money. Or it is a cure for cancer, but it's not being funded by Big Pharma.
This exciting project, I wanted to ask you a little bit about DNA and space and all of that. Can you explain exactly what your hardware or your project idea is?
Sure. So this project is a mRNA expression assay. It's a yes-no assay. So we're seeing if this mRNA is present or not. Now, mRNA is the intermediary between DNA and protein. DNA is in all of your cells. mRNA is copied selectively to make the proteins that each one of those cells needs. But proteins are really different and hard to extract specifically.
And this idea of putting this up in space, and why is space important in this understanding of this as well?
Why space? Well, NASA's been shooting at bacteria into space forever. They're really curious about what bacteria are going to do up there. And so they shot up about 100 different species of bacteria, some often grown on the International Space Station. Their first concern was, will these bacteria grow in space? Because we were concerned about messing up those pristine planetary environments that we haven't touched. But now we're kind of concerned about, well, are those bacteria going to harm us when we go to Mars? And that's actually a very valid concern. We have found that some bacteria indeed become more deadly in space. And that's something that this project is going to address.
I was also interested in hearing a little bit about the hardware as well, and how it works. Could you describe a little bit more?
Yeah, so right now, the equipment is big and bulky. If you're going to look at mRNA, you are going to grow up some cells, you're going to extract the mRNA, and that's pretty straightforward. But then you're going to need a bulky PCR machine to make more copies. And then you're going to wash it over a plate with special reagents that have fluorescent dyes. And then you're going to have a huge fluoroscope to look over that. And then you're going to have a specialized technician to do it. That's a lot. What we're developing is one that's small. It's going to use a lot less reagents. You're going to basically load in your bacteria, and then it's going to run automatically with very little exposure and chance of exposure for the researcher or contamination of the project. And then what comes out is a yes or no assay. So we're making things smaller, cheaper, and more efficient and simpler.
That's great. You told me earlier when we spoke on the phone that there was some international aspect of this project as well. Can you describe that?
I'm kind of like piloting the first international biohacking project to build collaboration between some 30 biohacking spaces around the world. Now, not all 30 are participating, but we have a team in Australia, a team in Austria, and a team in Germany, all inputting their expertise and their know-how and their time on this project. And so Australia is helping with some of the prototyping and fabrication because it's cheaper down there, down under. Mm-hmm. Austria is helping out with this space knowledge. They've done some CanSats in their recent past. And then Germany's helping out with our microfluidics design.
Fantastic. So I also am very excited about the future of this project. Can you tell me what is your goals for the future of this idea?
Right. We're shooting for space,
Mm-hmm.
Quite literally, going for the stars. But this is an assay that could be used for biohacking spaces to do mRNA expression. It's a common assay used in biology, but also researchers. I think the main application that I'd like to see is for point of care. And so I think that there's a lot of room for that.
Mm-hmm. What kind of future goals do you have for this? What would be your dream as a result of this, moving this idea forward?
Yeah, it's kind of a surprising answer, but a cultural change, a change in mindset. Right now, the tools of diagnostics are with these big companies, and they're great. Like Genentech is great, Life Technologies is great, but in order to use those technologies, you have to have a degree almost to really understand what's going on. We're trying to make a tool that anybody can understand and anybody can manufacture. So really kind of changing how innovation happens, and that's that kind of cultural change in the mindset of the United States and the world.
The other thing that I was very curious about is how can people out here, help you to move this idea forward?
We're always looking for more collaborators. Come down to the lab in Oakland, Counterculture Labs. We have hack days every other week, and we're moving that project forward this way. Do you have access to a clean room to make the fluidic chip that's going to go to space? Awesome. Let's talk. I love partnerships. Partnerships for the biologics as well, to do some of this prototyping so it kind of is cheaper. It's pennies on the dollar to make biologics. It's very expensive to buy. So we're going to do a lot of trial and error, and that will cost some money. And then lastly, eventually we're going to do a crowdsourcing campaign to shoot this into space. So be looking for that.
Great. I want to just go back to the beginning again and just ask you how you got, a little more about how you got into this, just even biology in general, or did you just wake up one day and get excited about this idea of science? Or
well, that's a great question. Nobody in my family on my mother or father's side has a science degree or an engineer degree. They're all, I guess, restaurateurs or work for the government in one way or another. I've always been really curious. And so I've always had an interest in science in one way or another. But when I was in high school, I was going to go become a chef. Be the best chef in the world. But after going to college taking some courses in philosophy and linguistics, I didn't know what I wanted to do. I had like 100 hours at the community college, and I took a year off. And I kind of came around that I wanted to do something which is save the world. And I found the fastest track to having an impact was with science. And now kind of building these community labs, I'm even more on that mission than I had possibly or could have possibly ever imagined.
Yeah, I know that we do have representatives from the biohacking community attend the BioLink Depot. And it seems like these are people who are dedicated and excited about doing these types of things that can bring biology to the regular community as well.
BioLink Depot supplied like half of our equipment for free, and we also often get consumables here. So that means like the plasticware and stuff that we use once and throw away. And that stuff is actually really expensive for just being polystyrene. And for my personal project, we have to prove things at the lab scale before we shrink it down to microfluidics. Make sure that the things that we assume are going to work on the chip work in normal laboratory conditions. And so the equipment, the reagents, and all the things that come with it were kind of brought to us by BioLink Depot.
Great. It's good to know that the BioLink Depot has helped and contributed to this as well. It's exciting to hear how it's been applied.
Absolutely. I imagine I can't even wait to hear more about like your teachers, and that's the major service that you provide to the community.
Right.
So, yeah.
No, absolutely. The teachers, again, when we inspire the teachers to get access to supplies and things like this, we're able to they can actually get interested in biohacking themselves and maybe join counterculture labs.
Absolutely. Who knows? Or just come and get some, hands-on experience doing the stuff that they're going to have to teach their students.
Well, great. Well, I wish you a lot of success with this idea. I'm excited. I'm sure the viewers are just as excited about this as well. And I hope that this kind of brings awareness to this idea, this project, and that we can do this wonderful thing up in space. So thank you very much.
We have a web page. They can go to www.socializedscience.com/hardware.html. But Counterculture Labs also has its own website. That's www.counterculturelabs.org.
And BioLink Depot also has its own website.
Oh, great.
It's biolinkdepot, all one word, .org.
Awesome.